Hello and welcome! Over here we are looking at a question involving nuclear physics, which is an actual past paper question from CIE IGCSE Physics Paper 2. The question here says that a beta particle is fast-moving electron. Which statement explains how beta particles are emitted from an atom? A lot of students will mistakenly pick option B as their answer. Now this is understandable since in chemistry, when the electrons are emitted, they are often the valence electrons where they actually come from the outer electron shell of an atom. But in this case, we are looking at the nuclear physics, which is vastly different from the chemistry. If you look at the Rutherford's model of atom, which is not really the most accurate atomic model that we have today, but this is simple enough for our analysis over here. We can see that an atom is made up of a nucleus in the center with a bunch of electrons orbiting around the nucleus. Now in nuclear physics, we often ignore the electrons that are orbiting around the nucleus, since nuclear physics is, well, the study of the nucleus. So in our analysis of nuclear physics, we will often only look at the nucleus. So if that is the case, then where does the beta particle come from? Let's look at a specific example of beta decay. Here we have a tritium, which is an isotope of a hydrogen. It will go through beta decay and turn into helium-3 nucleus, accompanied by beta minus particle, which is really just an electron. But if we look deep inside, it is the neutron inside the hydrogen isotope that has undergone a decay. The neutron in this case decays into a proton accompanied by an electron. As the neutron decays into a proton, the proton will be reabsorbed by the hydrogen isotope, and hence their proton number will increase by 1 and become a helium nucleus. This is the reason why the element of the nucleus changes during a beta decay. The electrons, on the other hand, will be released as a form of beta particle. A lot of confusion usually comes up over how this actually happens. Those of you who have learned particle physics in A-level, you have learned that the entire beta decay process is mediated by a nuclear weak force. A nuclear weak force is capable of changing the flavors of a quarks. In this case, we have a neutron which is made up of an up quark and two down quarks, where one of the down quark can undergo beta decay and turn into an up quark. Therefore, due to nuclear weak force, we now have a hadron that consists of two up quarks with one down quark, which is essentially a proton. But now we have a problem. Initially, a neutron is neutral. After the decay, it becomes a proton which is positively charged. So we now have a violation of the conservation of charge. So in order to continue to make sure that the conservation of charge stays true, an electron which is negatively charged is released. However, even in this case, now we have another problem. A neutron is made up of quarks, and a proton is also made up of quarks. But suddenly now we have leptons that come out. So now the lepton number is no longer conserved. So again, in order to make sure that our lepton number is conserved, we need to release another particle, which is the antineutrino. So now we have a lepton number of 1 from the electron and the lepton number of -1 from the antineutrino, and therefore it will go back to a total lepton number of 0. So finally, coming back to this question, where does the beta particle come from? During a negative beta decay, essentially a neutron changes into a proton, and it's during that process a beta particle is emitted from the nucleus. Therefore, the answer is C. And that is it.